what would it be like to understand climate change in augmented reality with an AI assistant? That's what we've been working on. Let me show you. What we're looking at here is global sea surface temperatures. We've got 40 years since 1980 going back in time, and each one of these rows is a year. Let's spin this around and bring the most recent years up front. So take a look at 2016, that green line, and 2023, the most recent year. Filter to show 2016 to 2023. So I'm just going to talk to ChatGPT, and it's going to go ahead and filter out those prior years. We just don't need to see them, and we can really see that 2016, which was the last El Nino year, which means warm sea surface temperatures, and how that relates to 2023. We're going to come back to 2016 as we move forward here. Remove the filter. So let's take a look at a slightly different data set. This data set, instead of being sea surface temperatures, is northern hemisphere land temperatures. And this is just the anomaly. So this is what is different from the norm. You can see this line, this grid down the middle, that is the norm for the 20th century. You can see that the older temperatures here, all the way back to 1850 for each month, where in the older years, the temperatures were lower. And then more recently, we've got these 2016s on some of these months, particularly in the months of January, February, March. 2016, 2015, that was the last El Nino year. So there's definitely a relationship between land temperatures and El Nino and sea surface temperatures. Let's spin this around a little bit. Put this on a 3D radar chart. We're going to ask ChatGPT to spin our data and give us a new visualization of it. And look at that. This, we call it a 3D radar chart. Again, we're looking at time going down the center. Around the surface is each month, starting from January 1 all the way to December. And the farther the dot is from the center, the warmer it is. Again, we've highlighted the maximum year for the maximum temperature within each year for that month. So you can see January and February. And look at the big gap between 2016 and some of the prior years that, that would be closer to the norm. So let's switch to a slightly different view. Again, we're going to be looking at global land temperatures, but this time we're just going to go back to 1950. We're going to see that increase in temperature over the last 70 years. But we're going to colorize the data based on the El Nino La Nina cycle. So a El Nino La Nina cycle is about sea surface temperatures in the South Pacific. You can see that our last strong El Nino was 2016, and typically lately we've been in a weak or a moderate La Nina, actually quite long moderate La Nina. So our temperatures in the ocean have been quite moderated compared to what we saw last time we had an El Nino in 2016. But a new El Nino has formed in the South Pacific, and we're going to see what that might bode for the future. So let's just focus directly on the Oceanic Nino Index. In fact, maybe we want to find out what is the Oceanic Nino Index. What is the Oceanic Nino Index? So we can just ask ChatGPT. And it's going to go ahead and start to build this structure in 3D space to help describe to us some of the aspects of Oceanic Nino Index. Here we go. We can see certain aspects of the Oceanic Nino Index. We can see that the El Nino is a climate pattern characterized by warmer than average temperatures, and La Nina is cooler than average temperatures. And it also describes how and where are we looking at temperatures in the ocean in order to gauge the overall temperature. Tell me how this affected Mongolia. So we're going to use this data point as context for ChatGPT, and we'll see exactly how this impacted Mongolia. We can see that there was a drought that led to widespread food insecurity, specifically because of its impact on grazing animals, which is such an important part of the Mongolian culture and diet. So now let's bring together these two data sets. across the horizontal axis, we still have the global temperatures. You can see that slow rise. But on this depth axis, we have the oceanic Nino index. So over here in these green areas, this is cooler than normal temperatures. And in the red areas, that's warmer than normal temperatures. Remember 2016, you can really see it standing out here. We had warm sea surface temperatures, and we also had warm global temperatures. But what's crazy is that we have had this relatively cool temperatures in the South Pacific for about 2 years, and that has probably had a moderating effect on the temperature of the planet for this last several years. And that's the predictor of the future here that we're so interested in and concerned about. If this cool temperatures in the South Pacific are over and we're back to a very warm pattern in our ocean temperatures, what's going to happen to our global temperatures as we move forward into later this year and the fall, as well as we can already start to see it in these last few months, these really extreme warm temperatures. June was the warmest June in history, and it all seems to be tied back to what's happening in the ocean temperatures. I hope this is a really interesting view to understand both climate change, an interesting way to visualize it, and how we're starting to work with AI to help us understand what we're seeing and be able to manipulate it just with our voice. Kind of like Iron Man. Thanks for watching.